today we will see another algorithm, that is the Cyrus-Beck line clipping algorithm in computer graphics. So the topics that I am going to cover in this Cyrus-Beck line clipping algorithm are: what exactly the Cyrus-Beck line clipping algorithm? We will see the algorithm in step-by-step manner, and we will work out that example algorithm by taking an example. And finally, we will see what are the advantages and disadvantages of using this algorithm. Okay, so the Cyrus-Beck line clipping algorithm, which is used for the convex polygons. So we generally used for the convex polygons. Actually, there is a disadvantages in Sutherland line clipping algorithm. So Sutherland line clipping algorithm is also there. So there some disadvantages are there. That disadvantages in Sutherland line clipping algorithm. There the polygon should be it considered only the rectangular polygons. Okay, the Sutherland line clipping algorithm considers only the polygons that are in rectangular shape. So it is not considering the other than the rectangular shape. Okay. So to overcome that disadvantages, this Cyrus-Beck line clipping algorithm were introduced. So whereas in this algorithm, this Cyrus-Beck line clipping algorithm, we are considering non-rectangular windows also. Okay. It can perform line clipping on non-rectangular windows also. Okay, so so generally it is used for the convex polygons. Consider an example. Let the given input is a set of a coordinates of the convex area of interest, which are in a clockwise fashion. The vertex x comma y and n number of vertices are there. A line that has to be clipped is a set of coordinates, and array of coordinates are x0, y0 and x1, y1. So then what will be the output? The line clipping coordinates are accepted clipping and rejected clipping coordinates are -1 comma -1. So what it mean? So let us consider a triangle, which is a non-rectangular window. So this is a line. So we need to clip this line. So we have to find the intersection points. So they are given an array of coordinates. So say here x0, y0 and this is x1, y1. Okay, so the line has to be clipped, whatever it is there, that inside has to be accepted and outside should be the rejected part. Okay, now let's see the algorithm. First I'll explain, I'll just show you this algorithm, and if you didn't understand this algorithm, it's okay, we will work out with an example. So by seeing an example, you can get the complete clarity on what exactly this Cyrus-Beck line clipping algorithm is. So in this algorithm, every edge of normal edge is calculated. Okay, so if you consider a triangle, so these are the intersection points that we need to be find out. Okay, this is P1 and this is the P0. Let's take P0 and the P1. Okay, so we need to find the normal edge. So normal edge has to be calculated. So at this edge, you can consider any one at any point one normal edge. Any point. So this is a normal edge. Clipping line of vector is calculated. We have to find the clipping vector of a line. Perform the dot product operation between the difference of one vertex per edge and one selected endpoint of a clipping line, and the normal of the edge is calculated. Perform the product operation between the vectors of the clipping line and the normal edges is calculated. So we are considering one more points like point at edge. Point at edge P1, so P1, P2, so P3, like that. A point at edge has to be calculated. And we have to perform the dot product on normal vector and the point edge. Point at edge. The former dot product is divided with lateral dot product by and multiplied by -1. That you get the time t. So what is our main motto here? We have to find the time generally. First find the time, then we will find out the intersection points. So here P0 the line starts and the P1 the line ends. So at time 0 P0 is started. Okay, at the time 1 P1 is ended. So we need to find at what time the intersection has occurred. So that can be found out by using the dot product, okay, and that dot product is divided with the lateral dot product and it has to be multiplied by -1. The value of t or entering or exiting from all edges by observing the denominators. From each group, one value of t has to be chosen and represents into parametric form of a line to calculate the coordinates. Suppose the enter t value is greater than the exiting t values and the clipping has to be rejected. So let me explain you with an example. First see this example, then we will work out that how to calculate the t. Okay, the time period t, how we are going to calculate it. We'll apply that algorithm, then you'll get the parametric equation. Okay, means we are applying on the parametric equation only. So there is a parametric equation, p of t is equal to p naught plus t into p1 minus p naught. So you know the p naught, that is the starting point of a line, and p1 is the ending point of a line, and we need to find out the time. So at what time these 2 points are intersected. Okay, so at 2 points, this 2 point line, this line is going to be intersected for the polygon, that we need to be find out, right? So see here, in the clip, this is a polygon. Here a clipping window intersect points coincides with the end points, intersects points or coincides with the end points. This is one condition. Okay, case 1. So this is partially inside, and here one and when point is intersected, only one intersection point is there, and this is completely outside, and here two intersection points are there. Case 1, line is partially inside the clipping window. Suppose if this is partially inside the clipping window, then the condition is 0 is less than entering, time at entry, time at exit less than 1, where t is the entering intersection point and tx is the exiting intersection point. Suppose line has one point inside or both inside the window or intersection point or at end. Means three conditions are there. One point is inside, both sides inside the window or intersection points are on the end point of the line. Then what is the condition? So the 0 is less than or equal to time at entry, less than or equal to time at exit, okay, less than or equal to 1. So where t is the entering intersection point and exiting intersection point tx. Suppose if the line is completely outside the window, then you can reject it. That is tx is less than te. Okay. So now before working on the example, let's calculate. I said the case 1. So what is the case 1? The case 1 is find the normal vector. So the normal vector is, let's take the normal vector is outward. So that is ni, where I is the edge number. And the case 2. Case 2, that is step 2. Take point anywhere on the line. Take point anywhere on the line. That is PEI we used to call. That is point at edge I. Then finally the case 3. Find the dot product. Find dot product. So we need to find the dot product. Okay, so the dot product is Ni into P of t minus PEI. Okay, suppose this dot product is less than 0. Less than 0, that means P of t is inside clipping. P of t is inside clipping. Suppose if it is greater than 0, then P of t is outside clipping window. Outside clipping window. Suppose if it is equal to 0, then we will find the intersection point. So we'll get the intersect point. So that means n of I into P of t minus P of is equal to 0, then only we will get the intersect point. So now what we are doing here? So what we are doing? So we are doing, so ni, we have to find the intersection point. So the time at the intersection point is equal to 0. Now ni into, so p naught plus t into p1 minus p naught minus PEI. So what is this P of t? The P of t is nothing but the parametric equation. So this is a parametric equation. Okay, substitute in place of P of t, the parametric equation. So if you calculate this, so you'll get t is equal to, so if you do the dot product and you will get t is equal to ni into PEI minus P naught by Ni into P1 minus P naught. So don't cancel this Ni because Ni is a vector. So you're not supposed to cancel it. Okay. So using this parametric equation, we have to find the intersection point of a line with the boundaries of the clipping window. Okay. So now let us consider an example. So I'm just drawing my polygon. So let's take, this is my polygon. Okay. So this is my polygon and the intersection line, let me take, this is my intersection line. Okay. So 1 second, let me take. Okay. Okay. Fine. So my polygon is, this is my polygon. Now the intersection line, let me take, so this is my intersection line. So this is, let's take P naught and this is P1. Okay. This is P naught and this is P1. So what I have to do, I have to find the intersection point. So this point I need to be find out, intersection point. So the P naught, let's take the values or P naught values, let me take -2 comma 1 and the P1 values or let's take 6 comma 3. Okay. P naught is -2 comma 1 and the P1 is 6 comma 3. Okay. So let's consider the vertex. The vertex or this is V1. Okay. And this is the whatever, this is V2, V3, V4, V5 and V6. These are the vertex. So now I have to find the normal vector. The normal vector is n. So n means it is coming towards, right? Okay. So this is n1, this is n2, somewhere else n3, n4, n5 and 6. Okay. So when time t is equal to 0, P naught value is this. When time t is equal to 1, P1 value is this. At what time this is the intersection point? At what time the point, there is a intersection point will occur? At what time? We need to find the time. So for finding time, what is the formula? T is equal to Ni into Pei minus P naught by Ni into P1 minus P naught. So what is this Pi? Pi is nothing but the point at edge. So point at edge, let's take the vertex or the point at edge. Let's take the vertex or the point at edge. P1, P2, P3, P4, P5, P6, the vertex at the point at edge. Okay. And what is the parametric equation? P of t is equal to P naught plus t into P1 minus P naught, right? Now let's take the step 1. So apply the algorithm now. Step 1. So first find the n1. At n1, x value is increasing or decreasing? X and y values are increasing or decreasing? See here, this is coming downwards. Downwards means x is decreasing as well as y coordinate is also decreasing. Both are decreasing. Both are decreasing. That means n1 is -1 comma -1 if both are decreasing. At n2, let's take n2. So n2, x is decreasing, y is no change because this is at y is constant here. So x is decreasing and y no change. So that means what? So n2 is x is decreasing, y no change. So at n3, so n3 is what happening? N3 is going up this right. So here x is decreasing, y is increasing. X is decreasing stage. It's coming like this. It's leftwards, and y is increasing. X is at n3. X is decreasing, and y is increasing. So that is n3 is equal to -1 comma 1. So now n4. So n4, see here. In n4, x is in increasing state and y no change. sorry, y is also increasing, both are increasing. So n4 is 1 comma 1. At n5 is x and y increasing and y no change. X is increasing and y no change, 0. And finally n6 coming down. So x is increasing and y is decreasing. So 1 comma minus 1. So these are all the normal vectors. Now you have to find out the step 2. So what is the step 2? The step 2 is at point edge PEI. So the PE1 is nothing but the xy values, that is the vertex value. So whatever the vertex value, so let us take the vertex values. I am giving V1 is 3 comma 0 and like that V2 is, so I am giving the vertex value. So vertex values are same as the point at edges. Let's take 3 comma 0 and PE2 1 comma 2 and PE3 let's take 1 comma 4 and PE4 3 comma 6 and PE5 it's like 5 comma 4 and P6 is come 5 comma 2, PE6 5 comma 2. Now step 3. So step 3, calculate the T1 value. First calculate the T1 value. T1 value N1 into P1 minus P0 by N1 into P1 minus P0. So what is the N1 value? We are just now calculated. N1 is minus 1 comma minus 1. So minus 1 comma minus 1 into P1 is 3 comma 0 minus P0 is minus 2 comma 1. I already given at the starting. Okay, divided by minus 1 comma minus 1, 6 comma 3 minus 2 comma 1. So if you perform the calculation, you will get minus 4 by excuse me, minus 4 by minus 10. So similarly, if you apply this, T2 you will get minus 3 by 8. T3 is you will get so around 10 by 6 minus 6. Okay, sorry, 6 by 6 you will get 6 by minus 6, and T4 you will get it as 10 by 10, and T5 you will get 7 by 8, and T6 you will get 6 by 6. Okay, so 6 by 6. So if you perform the calculations here, these are the negative values. So here the T1, T2, if you consider T1, T2, T3 is less than 0. The value here it is less than 0 if you perform. Whereas T4, T5 and T6 denominators. So I'm talking about the denominators. Denominators is less than 0. And T4, T5, T6 denominators are greater than 0. So when the denominators are greater than 0, you have to choose the lowest value here. In this 3, you have to choose the lowest value. In this 3, the denominators is less than 0. Okay, if the denominators are less than 0, then we have to take choose the highest value. So this is the highest value. Okay, so now the entering time is minus 4 by minus 10, and exiting time is leaving time, or else you can type leaving time is 7 by 8. So the leaving time is 7 by 8. Now with the help of the entering and leaving time, we will find the intersection point, right or wrong? We can find the intersection point. So P of t is equal to P0 plus P1 minus P0. Okay, P1 minus P0. So substitute the, so at entry. So now we are seeing the entering time. Entering time. So P0 is minus 2 comma 1. Okay, into t. So P1 is, let's take 4 by 10. And this is 6 comma 3 minus 2 comma 1. So now if you perform the calculation plus 4 by 10, you will get it as 8 comma 2, and finally you will get 6 by 5 comma 9 by 5. So now leaving time. So leaving time P of t is equal to, if you substitute, you will get minus 2 plus 1, 7 by 8. Anyhow, this value is 8 comma 2. So then you will get 5 comma 11 by 4. So these two are the intersection points. Intersection points. Okay. So in a graph, if you see, okay, these two are the, so this is over here. These two are the intersection points. These two are the intersection points. So the point at entering, this is 6 by 5 comma 9 by 5, and this is 5 by 5 comma 11 by 4. So this is how you can find the intersection point, and you can clip the line that is present outside the window. So this is this is the way we have to calculate the Cyrus-Beck algorithm. Okay, so the advantage of using this algorithm is it is more efficient when compared to the Cohen-Sutherland algorithm, which uses the repetitive clipping. With a convex polygon clipping window, it can be used, unlike Cohen-Sutherland, that can be used only on a rectangular clipping area. Then what about the disadvantages? The main disadvantage of using this algorithm is that it can be applied only to a two-dimensional clipping, whereas other methods like Liang-Baskis and the Cohen-Sutherland can easily extend it to three dimensions. So here we can't extend it this. It is dedicated to two-dimensional clipping only. Okay. So this is about the Cyrus-Beck line clipping algorithm. Still, if you are facing any doubts, please let me know. Thank you.